So this example will illustrate to you the concept of perpendicular bisector passing through the center of a chord. So for the first part, they just give you a very generic two coordinates, P and Q. So they give you a generic two coordinates, and then you do the perpendicular bisector. So that one, you just apply your general 4 steps. The 4 steps that you already learned in your amath chord job. So you just do your 4 steps and you get the perpendicular bisector. So the second part is the application. So right now in the second part, P and Q are on a circle. So P and Q passes through a circle. So that is a phrase that some students cannot understand. They cannot understand what does it mean by a circle passes through P and Q. A circle passes through P and Q is just as good as that 2 coordinates are on the circumference. And because that 2 coordinates are on the circumference, that means essentially they form a chord. So that is the implication of that statement, which some students cannot understand. And then they mention something about center lying on a particular straight line. And then your job is to find the equation. So the thinking process will be very simple. In order to get the equation of a circle, I will need 2 items. I will need the center and I will need the radius. So if I can get the center and radius, I plug it into the general form and do my expansion. So in this question, you got to apply that the perpendicular bisector will pass through the center. So from the first part, we already gotten the perpendicular bisector. So this is not the extreme case. This is not the extreme case where the chord is vertical or horizontal. So this is the kind where it is in a way slanted. So that is the perpendicular bisector. So I will know that the center is somewhat along that line. And then the question gave us another information. The center also lies on this line. There's an extra line given here. So this extra line is so somewhat so we just know that it's -1. You can just generally just draw it. Doesn't matter where you draw it. So this is the line. So the center is cutting. That means, right, the center is on the perpendicular bisector and the center is also on the given line. So the center is on the perpendicular bisector. The center is also on the given line. So that's where you do your simultaneous to get your center. So execute your simultaneous equation. That will give you the center. So from here, the center is 2 minus 3. So my diagram isn't very accurate. It doesn't matter. Okay, my diagram is not accurate because there could be another circle on this side. The circle could be on this side. Because they also share the same chord. So I wouldn't know which side is it. So it doesn't matter. It's just a diagram representation. So with the center, your job is to get the radius. So where is the radius? So if you know center. If you apply your length formula, that will be the radius. So you apply the length formula from the center to P or Q, it doesn't matter. So from here to P, from here to P, you apply the length formula. So you apply the length formula. You get a 5. So the radius is actually 5. So from here, once you get the center, once you get the radius, the equation of the circle is found easily. It will be x minus 2 square, y plus 3 square equal to 5 square, and you carry on your expansion. So this is a very simple illustration of how we use the concept of center lying on perpendicular bisector of chord.